friends, welcome back. Now, in previous videos we are completed very systematically the concentration terms and ways for expressing the concentration of solution. As all you know very well, before this I am discussed with you the first way by using that we express the concentration of solution. That first way is called as the molarity. The second way is called as the mole fraction. Sorry, the first way is the percent by weight, percent by weight as well as percent by volume, and finally mole fraction. Now, in this videos I am going to discussing with you the next way by using that we express the concentration of solution. That next way is called as the molarity. Now, dear students, what is the meaning of molarity or how to define this? The molarity of a solution is defined as number of moles of solute present in 100 ml or 1 liter of solution. This is called as the molarity. Number of moles of solute present in 1000 ml or 1 liter of solution is called as the molarity. Now, the very highlight point, very important point present in the molarity, the unit, it is expressed in capital M. Listen very carefully. The molarity is expressed in capital M. Listen very carefully, because another concentration term is there. That another concentration term is called as the molarity. Therefore, it is expressed by using capital M. The next unit of this phenomenon is also we considered here. The next unit is called as after the molarity. The next one, the molarity depends on temperature. This is also very important, because the in molarity we use here volume of solution. The second expressed in capital M. It depends on, listen very carefully, write down in your notebook, it depends on temperature, because molarity changes with the temperature. And third important thing, unit of molarity is, listen, unit of molarity, listen very carefully, this also very important. Unit of molarity is mole per dm cube, or we people say like this, mole per liter. So mole per what? Liter. So this is the important point of molarity. Now, dear students, what is the formula related to this? Formula is equal to, therefore molarity is equal to, very simple formula, molarity is equal to moles of solute, listen, moles of solute divided by what? Divided by volume of solution, divided by volume of solution in moles of solute divided by volume of solution in liter. If we consider volume of solution in ml, then the same formula become, see toward this, moles of solute, listen, moles of solute divided by what? Divided by volume of solution in ml, moles of solute divided by volume of solution in ml into how much? 100, that one is called as the 1000. Now, you know very well, moles of solute we calculate by using formula, you know very well, moles of solute is equal to, how to calculate the moles of solute? Listen very carefully, moles of solute is equal to, the mass of, listen, the mass of solute divided by molar mass of solute divided by molar mass. Now, come toward this, put this value inside of this. Therefore, capital M or molarity is equal to, capital M is equal to, what is this? Mass of solute, capital M is equal to mass of solute divided by what? Molar mass, because listen very carefully, mass and molar mass is must be same unit. Either if it is in gram, then it is in gram. It is in kilogram, then it is in kilogram. Then into volume of what? Into volume of solution in liter. Okay. The in short notation we say mass of solute is nothing but W2 divided by molar mass of solute, means what? Molar mass of solute is nothing but the M2 into volume of solution, that is into what? V means what? Volume of solution. If this V in liter, it must be in liter. If this is in ml, therefore M is equal to W2 divided by M2 into V in ml, then you must be put here 1000. This is called as the formula. By using that we calculate the molarity. So, as per my idea, you don't have any problem related with this phenomenon. So, what is the meaning of molarity? The molarity of a solution is defined as number of moles of solute dissolved in 1000 ml or 1 liter of the solution. it is expressed in capital M, it depends on temperature, and unit of molarity moles per dm cube or mole per liter. Therefore, molarity is equal to moles of solute divided by volume of solution in liter. Therefore, as per my idea, you don't have any problem. This is the formula because moles of solute, volume of solution ml into 1000. How to calculate the moles of solute? Moles of solute is equal to mass of solute divided by molar mass. Therefore, capital M is equal to mass of solute divided by molar mass into volume of solution in liter. Therefore, capital M is equal to W2 divided by M2 into V in liter. Therefore, capital M is equal to W2 into 1000 divided by M2 into V in what? ml. So, these are the way by using that we considered here molarity. Now, dear students, after molarity, now we are going to the next way by using that we express the concentration of solution. That way is called as the molality. Listen very carefully. Molarity and molality. Now, what is the meaning of molality? See, this is the second way by using that we express the concentration of solution, which is called as the molality. Now, dear student, now how to define the molality? Which are the important things here? Molality of a solution is defined as, it is defined as number of, see, before going to define, denoted by capital M, denoted by capital M. What is the definition? Number of moles of solute. See here, number of moles of solute present in either 1000 gram, present in 1000 gram or 1 kilogram of, this is not solvent, this is not solution, this is the solvent. Keep in your mind, this is the major difference between molarity and molality. What is the meaning of molality? The molality of a solution is defined as number of moles of solute present in 1000 gram or 1 kilogram of solvent. That one is called as molality, denoted by small m. Is it okay? Now, dear student, what are the highlight points? So, keep in your mind, number of moles of solute present in 1000 gram or 1 kilogram of solvent. This is nothing but the molality. Another important things related to the molality, which is the next important things. This is highlight point. It is expressed in. Write down in your notebook. It is expressed in small m. Then second important point, it does not depends on temperature. It does not depend. It independent on temperature. It does not depends on temperature. Therefore, this is the best way by using that we express the concentration of solution. If anyone asks you the question, suppose in front of you, you have a normality, you have a molarity, you have a mole fraction, and if anyone asks you the question which depends on temperature, your answer is molality is the best way. It does not depends on temperature. That one is the molality. And another important, the unit of molality is mole per kilogram. Unit is what? Mole per kilogram. So, this is the very interesting phenomenon related to your molality. Now, what is the formula of this molality? Therefore, molality is equal to moles of solute is equal to, very simple, molality is equal to moles of solute divided by mass of solvent in what? Mass of solvent in kilogram. But you know very well how to calculate the moles of solute. The same things happen this also. Moles of solute divided by mass of solvent in gram into how much? 1000. But you know the formula calculation of moles of solute, because mass divided by molar mass, the same formula become molality is equal to, or small m is equal to the mass of solute, small m is equal to mass of solute. If it is in gram, then molar mass, then divided by what? Molar mass of solute divided by molar mass of solute into what? Into mass of solvent, if it is in kilogram, then no need to write 1000, or small m is equal to W2 divided by M2 into W1 if it is in gram, then W2 into how much it is? 1000. So, this is the way by using that we calculate the molality of a solution. So, as per my idea, you don't have any problem related to the molality also, dear students. This is a very simple things related to this phenomenon. Now, so keep in your mind, what is relation between molarity and molality? That relation we easily calculate by using density, because you know density is equal to mass by volume. Density is equal to what? Mass by volume. So problem, how which type of problem they ask you in the examination? I will give you some example related to molality and molarity, because these are the example are important example to you, dear student. Now see the problem based on molarity and molality. Problem based on molarity and molality. So the first problem, a solution of NaOH molar mass 40 gram was prepared. The solution of, write down in your notebook, a solution of NaOH molar mass 40 gram was prepared by dissolving 1.6 gram of NaOH in 500 ml of water. Calculate molarity of NaOH solution. Calculate molarity of solution. I will write a solution of NaOH. Listen, a solution of what? NaOH. A solution of NaOH. You know the molar mass, they are given to you, molar mass also. Molar mass they are given, that is 40 gram per mole. This is a molar mass of NaOH, 40 gram per mole. Was prepared by dissolving, was prepared by dissolving, how much? Was prepared by dissolving 1.6 gram of NaOH in 500 ml of water. By dissolving 1.6 gram of NaOH in 500 ml, cm cube means ml, 500 ml of what? 500 ml of water. 500 ml of water. Calculate molarity of solution. Calculate what? Molarity of solution. Calculate the molarity of solution. So this is the way, by using that we calculate the molarity. Now what are given? Listen student, these are the very interesting thing which are the given. They are a solution of NaOH molar mass was prepared by dissolving 1.6 gram of NaOH. They are given mass of solute, that is W2 is equal to 1.6 gram. No need to write, these are the very simple things. And they are also given the molar mass of solute, Mt is equal to 40 gram. Mass of solute is Mt is equal to 40 gram. They are also given the volume of solution, that is volume of solution V is equal to 500 ml. They are given to you volume of solution, that is V is equal to how much? 500 ml. If we consider in ml, then what is the formula of molarity? Capital M is equal to W2, that is mass of solute, divided by M2 molar mass into V volume of solution. If volume of solution in ml, then here we put here 1000. This is very simple things. Therefore capital M is equal to, what is the weight of solvent? 1.6 into how much? 1000 divided by M2 40 into how much? Into 500. So if we calculate this phenomenon, then this calculation become very simple to you, because if we consider in because why the unit of both are cancelled, because this is in gram, this is also in gram, that's why unit is 100% cancelled. No need to discuss all these things. Finally 1.6 into 10 raised to minus 3, therefore the same, this becomes 1.6 divided by 40 into 1.6 divided by 40 into 0. How much? 5, 0.5, because these two get cancelled, that's become the 0.5. And finally the answer of this is 0.08 mole, 0.08 mole per dm cube. Alakshat tumcha. So this is the very simple calculation related to you by considering the molality. Any objection? Is it okay? If unit is same, then it doesn't have any problem. Now come to the second way, second problem. Now second, which is the second, write down in your notebook, this is a very simple problem related to molarity. Okay. Now come to the second problem. 11.11 gram of urea was dissolved in 100 gram of water. See the second problem. I will repeat. 11.11 gram of urea was dissolved in 100 gram of water. 11.11 gram of urea was dissolved in 11.11 gram of urea was dissolved in 100 gram of water, was dissolved in 100 gram of what? Was dissolved in 100 gram of water. Calculate the molality of solution. Molality, they are asking you calculate the molality of solution. Calculate the molality of solution. Calculate the what? Molality of solution. Okay. They are asking 11.11 gram of urea. Once again they are given W2 is equal to 11.11 gram mass of solute. Dissolved in 100 gram, they are given you W1, they are given that is 100 gram of water. Calculate the molality. Very simple. You know the molar mass of urea, because they are not given the molar mass. I think you calculate the molar mass. How we calculate? You know the structure of urea, NH2 bond CO bond NH2. You know molecular formula of urea become N2 because 2 nitrogen atom, then CO, then finally H4, N2COH4. Then write down like this way, CN2HO4, H, and here finally O4. This is the molecular formula. Now atomic mass of carbon is 12 plus nitrogen 14, 14 2s are 28 plus how many hydrogen? 4 hydrogen plus oxygen. Oxygen is only 1, H4O. Oxygen is 1 means atomic mass is 16. Yes or no? This is 16. Add 16 plus 4, 20. 20 plus 28, 48. 48 plus 12, this becomes the 60. Therefore, molar mass of urea is 60 gram. Yes or no? This is 60 gram per mole. Very simple. Now, dear student, therefore M2 is equal to how much? 60 gram per mole. Very simple formula. Small m is equal to, what is small m? Small m is nothing but the molality. Therefore small m is equal to, dear student, W2 into 1000 divided by M2 into W1 in what? W1 in gram. Therefore what is the value of W2? 11.11 into how much? Into 1000 divided by 60 into how much? Divided by 60 into 100, because gram get cancel. Okay, and this is the 100 gram of solution. Therefore unit become the what is the unit? Mole per kilogram. Obviously mole per kilogram. 11.11 by 60 means number of mole. Therefore finally after calculating all this part, the value of this become the 0.1852 per, see value of this become 1.852 mole per kilogram. 1.852 mole per kilogram. So this is the unit. As you calculate direct or by using the number of moles, this is very simple things related to the second problem on the molality. Now dear student, come toward the next one. That one is called as, in one problem, so I will give you, calculate molarity and molality. See, both calculation we are considered in one problem, because if both are there, then how to use the density in the problem, this become very simple. Listen, calculate molarity and molality of sulfuric acid solution of density. Listen, third problem, calculate molarity and what? Molarity and molality. Calculate molarity and molality of sulfuric acid solution of density of sulfuric acid solution of what? Density. They are given the density 1.198 gram per cm cube, density 1.198 gram per cm cube. They are given the density are given in ml. Keep in your mind, this also very containing 27% by mass of sulfuric acid, containing 27% by mass of what? 27% by mass of sulfuric acid. And then finally molar mass, they are given 98 gram per mole. This is a molar mass given by considering the sulfuric acid. Now dear student, calculate molarity and molality of sulfuric acid solution of density 1.198 gram per cm cube containing 27% by mass of sulfuric acid. Molar mass they are given 98 gram per mole. Now listen very carefully, which are the important things. They are given 27% by mass of sulfuric acid. What indicate this 27%? 27% means 27 gram of H2SO4 present in how many gram of solution? 100 gram of solution. So this is the 100 gram of solution. So dear student, what indicate this? W2 is equal to 27 gram obviously, then W is equal to 100 gram, yes or no? Therefore what is the W1? W1 is equal to W minus W2, that it become 100 minus how much? 27. Therefore 100 minus 27, this become the 73 gram, yes or no? The mass of solute becomes, mass of solute become the 73 gram. Once if you know mass, then we calculate, now they are given density. What is the density? Is equal to 1.198. On the basis of density, we calculate the volume of solution, yes or no? We calculate in place of 1000 gram, how much volume of solution is there? Volume of solution is 100 gram. Then we convert 100 gram into, therefore volume of solution is equal to, see toward this, therefore density is equal to 1.198 gram. And W, that is mass of solution, is equal to 100 gram. Obviously mass of solution W is 100 gram, na? 27 gram of sulfuric acid means W is 100 gram. Therefore density is equal to mass by volume. Therefore volume is equal to mass into density, yes or no? Density is equal, therefore volume is equal to mass by density, yes, correct, mass by density. Therefore they are given volume is equal to mass, they are given how much? Mass 100 gram divided by density 1.198. Therefore volume of solution become how much? Volume of solution become 83.47 ml. Volume of solution is 83.47 ml. Keep in your mind, unit of density is gram per cm cube, gram per ml. Therefore you must be calculate the volume in ml, you consider, because if it is in ml, then mass is must be in gram. This 100 gram ml. If it is in dm cube, mass in kilogram. So keep in your mind, this is a volume of solution. Now calculate small m. Molality is equal to W2 into 1000 divided by M2 into W1 in gram. Dear student, very simple. What is the value of W2? 27 into 1000 divided by M2 is, what is the value of M2 divided by 98 into W1 in gram, how much? W1 in gram is 73. This is a very simple things. As per my idea, we don't have any problem related to this phenomenon. 73, but we considered 73 in gram, therefore no need to discuss more things, because the unit of 27 is also gram, unit of 98 is also gram, and unit of 73 is also gram. Is it okay? Because gram get cancelled, but this is 1000 by gram. So same we consider like this way. So what it become? 27, we write this formula same way also. 27 divided by 98 into 73 into 10 raised to minus 3 kilogram. If it is in kilogram, then no need to write 1000. So finally, after calculation, the value of this become 3.77 mole per kilogram. So this is called as the small m, which is called as the molality. Now dear student, calculate the capital M molarity. Molarity is equal to, W2 divided by M2 into V in m liter, V in liter. Now this is volume in ml, you consider 10 raised to minus 3. Therefore capital M is equal to 27 divided by 98 into how much? Into 83.47 into 10 raised to minus 3 liter. Yes or no? This is in liter. Obviously this is a very simple things related to this phenomenon, and the value of capital M become 3.301 mole per dm cube. So these are the way, by using that we express the concentration of solution. So dear students, the remaining way, that one is called as the normality, we will discussing in the next video. Thank you very much.